The installation described presents significant safety hazards and clearly violates established electrical codes. Let's examine the specific violations and concerns. Firstly, exposed conductors lacking terminal ends or bushings create a direct shock hazard and the potential for arcing. The absence of proper termination methods leaves live wires vulnerable to contact, posing a serious risk to anyone in the vicinity. Secondly, conductors spliced using only rubber sheets represent a makeshift and completely unacceptable method. Proper splicing requires approved connectors and insulation techniques to ensure secure and reliable electrical connections. The rubber sheet method is prone to failure, leading to loose connections, overheating, and potential fires. Thirdly, running both power and communication lines such as telephone and cable television within the same conduit violates the National Electrical Code, often abbreviated as NEC. The NEC mandates separate conduits for power and communication lines to prevent interference, reduce the risk of electrical noise, and maintain safety. The presence of standing water within the manholes creates a dangerous grounding hazard and can cause significant damage to electrical equipment. Water is a conductor of electricity and its presence increases the risk of shock and short circuits. Additionally, the absence of gaskets or proper lockdown mechanisms for the manhole covers allows water and other contaminants to easily enter, exacerbating the problem. The reported waving motion of the floating docks during bad weather introduces another critical safety concern. This movement can cause conductors to rub against each other, leading to the degradation of insulation and the creation of an arc flash hazard. Arc flashes are extremely dangerous and can result in severe burns, explosions, and even fatalities. The combination of these factors results in several significant safety concerns. The exposed conductors and inadequate splicing methods create a substantial shock hazard for anyone working on or near the electrical system, or even just passing by. The potential for electrical fires is also greatly increased due to the improper splicing, damaged insulation, and the presence of flammable materials. Standing water and contaminants can cause extensive damage to electrical equipment, leading to malfunctions and further hazards. Given these serious safety concerns, the marina owner has a clear responsibility to ensure a safe environment. This includes ensuring that the electrical system is properly installed, regularly maintained, and compliant with all applicable electrical codes and regulations. Several immediate recommendations should be followed to address these issues. One should contact the local building inspector and report the unsafe installation to the appropriate authorities. This will initiate an official investigation and help ensure that the necessary corrective actions are taken. 2. One should notify the marina owner in writing, informing them of the specific code violations and safety concerns identified. This provides a formal record of the issues and emphasizes the urgency of addressing them. 3. One should consider contacting a qualified and licensed electrical contractor. A professional electrician can assess the situation in detail, identify all code violations, and provide recommendations for safe and effective repairs. 4. It is crucial to take personal precautions to protect yourself from harm. Avoid any contact with exposed electrical components and exercise extreme caution when near the manholes. 5. Document all concerns in detail. Take photographs and keep detailed notes of the unsafe installation for future reference, including dates, specific issues, and communications with the marina owner and authorities. Electrical systems in marinas require careful design, installation, and maintenance due to the unique environmental factors present. The combination of water, movement, and exposure to the elements creates a challenging environment that demands strict adherence to electrical codes and best practices. The NEC Article 555 specifically addresses the requirements for electrical wiring and equipment in marinas and boatyards. This article outlines the requirements for grounding, bonding, overcurrent protection, wiring methods, and other safety measures necessary to minimize electrical hazards in these environments. Key requirements within NEC Article 555 include the following: grounding and bonding all metal parts of the electrical system, including enclosures, equipment, and wiring, must be properly grounded and bonded together to create a low impedance path for fault currents. This helps to minimize the risk of electric shock and prevent the buildup of stray voltages. Ground fault protection. Ground fault circuit interrupters, often called GFCIs, are required in many locations in marinas, including receptacles serving boats. GFCIs detect small imbalances in current and quickly interrupt the circuit to prevent electric shock. Wiring methods. Wiring methods must be suitable for wet and corrosive environments. This typically includes the use of corrosion-resistant conductors, raceways, and fittings. Cables must be securely supported and protected from physical damage. Overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, must be properly sized and installed to protect conductors and equipment from overload and short circuits. These devices must be readily accessible and properly labeled. Shore power receptacles. Shore power receptacles must be of the locking type and must be protected from the weather. They must also be properly sized to match the amperage and voltage requirements of the boats they serve. Load calculations. Proper load calculations must be performed to ensure that the electrical system is adequately sized to handle the anticipated loads. This includes considering the loads imposed by boats, lighting, and other equipment. In addition to the NEC requirements, there are other industry standards and best practices that should be followed in marine electrical systems. These include regular inspections and maintenance, proper training for personnel, and the use of high-quality equipment and materials. Regular inspections should be performed by a qualified electrical contractor to identify potential problems and ensure that the system is operating safely. Maintenance should include cleaning and tightening connections, replacing damaged components, and testing ground fault protection devices. Personnel working on marine electrical systems should be properly trained in electrical safety and the specific requirements for these environments. They should be familiar with the NEC Article 555 and other applicable standards. High-quality equipment and material should be used throughout the electrical system. This includes using corrosion-resistant conductors, raceways, and fittings, as well as using properly rated and labeled components. Addressing the specific issues outlined earlier, the following steps should be taken. Exposed conductors. All exposed conductors must be properly terminated with approved terminal ends or bushings. These terminations must be securely fastened and insulated to prevent accidental contact. Improper splices. All improper splices using rubber sheets must be replaced with approved splicing methods. This includes using crimp connectors, heat shrink tubing, or other methods that provide a secure and reliable electrical connection. Mixed power and communication lines. Power and communication lines must be separated into separate conduits. This may require installing additional conduits to accommodate the communication lines. Standing water. The source of the standing water in the manholes must be identified and eliminated. This may involve repairing leaks, improving drainage, or installing sump pumps. The manhole should be cleaned and dried before any electrical work is performed. Missing gaskets and lockdowns. Gaskets and lockdown mechanisms must be installed on all manhole covers to prevent water and contaminants from entering. Damaged insulation. All conductors with damaged insulation must be replaced. This includes conductors that have been worn down due to rubbing or exposure to the elements. The electrical system should be inspected regularly to identify and address any potential problems before they become safety hazards. This includes visual inspections, electrical testing, and thermal imaging. A qualified electrical contractor can perform these inspections and provide recommendations for maintenance and repairs. It's important to ensure that all work in the electrical system is performed by qualified and licensed electricians who are familiar with the NEC and other applicable standards. This will help to ensure that the work is done safely and correctly. When selecting an electrical contractor, it's important to choose one with experience in marine electrical systems. They should be familiar with the unique challenges and requirements of these environments. They should also be licensed and insured to protect yourself from liability. The marina owner should also develop and implement a comprehensive electrical safety plan. This plan should include procedures for inspection, maintenance, training, and emergency response. The plan should be reviewed and updated regularly to ensure that it is effective. All boat owners and marina staff should be trained on electrical safety procedures. This includes how to identify potential hazards, how to respond to electrical emergencies, and how to use electrical equipment safely. The marina should also provide adequate signage to warn people of potential electrical hazards. This includes signs near manholes, shore power receptacles, and other electrical equipment. It's important to remember that electricity and water are a dangerous combination. By following these safety precautions, boat owners, marina staff, and visitors can help to prevent electrical accidents and ensure a safe environment for everyone. The presence of 408 three-phase power at the docks further emphasizes the need for strict adherence to safety standards. 408 volts is a significant voltage level that can cause serious injury or death upon contact. The higher voltage increases the risk of electrical shock and arc flash hazards. It's imperative that all electrical equipment and wiring are properly insulated, grounded, and protected to prevent accidental contact with live parts. The step-down transformer on each dock should be regularly inspected and maintained to ensure that it is operating properly. The transformer should be properly grounded and protected from overcurrent and voltage surges. The secondary voltage of the transformer should be carefully monitored to ensure that it is within safe limits. The electrical system should be designed to minimize the risk of stray currents in the water. Stray currents can cause corrosion of underwater metal parts on boats and docks, as well as pose a shock hazard to swimmers. Bonding all metal parts of the electrical system together can help to minimize stray currents. Ground fault protection should be used to detect and interrupt any ground faults that may occur. Regular water quality testing should be performed to monitor for the presence of stray currents. In addition to the technical aspects of electrical safety, it's also important to promote a culture of safety at the marina. This includes encouraging people to report any potential hazards, providing ongoing training, and recognizing and rewarding safe behavior. By working together, boat owners, marina staff, and visitors can create a safe and enjoyable environment for everyone. The information provided in this narration is intended for general guidance only and should not be considered a substitute for professional electrical advice. If you have any concerns about electrical safety at a marina, it's important to consult with a qualified electrical contractor. They can assess the situation and provide recommendations for safe repairs and maintenance. Remember, electrical safety is everyone's responsibility. By taking the necessary precautions, we can all help to prevent electrical accidents and ensure a safe environment for ourselves and others.